everyone. This is the video to our project, the Agentic Power Disease Surveillance and Outbreak Forecasting in Kenya. My colleagues for this project are Malvin, Sami, and I, Edgar. So the problem statement being Kenya is actually experiencing over 6,000 disease-related deaths every month, and many of which can be preventable through timely intervention. So we have diseases like malaria, cholera, and pneumonia, which affect millions yearly, and largely due to fragmented data systems. So apart from that, we have delayed reporting and lack of AI-driven insights. So what was our goal? We were set to build a real-world functional AI application using Microsoft Fabric. So one that doesn't just analyze data, but forecasts outbreaks, gives alert to decision makers, and also empowers health workers. So how did we build our project? So we utilized Microsoft Fabric, which is an end-to-end data analytic platform. So this helped us to build the end-to-end solution, of which we utilized systems such as Lakehouse. So in Lakehouse, we structured and cleaned our data. Then we used Dataflow Gen2 to ingest and transform data. Then Eventhouse for building a RAG application, and we utilized built-in machine learning models. So on ingestion, actually, there are many ways you can ingest data, but we used Flow API to bring in streaming data and CSV using Data Factory. Then we used the medallion architecture, of which we, from the raw files, we clean the data to the gold. So this is a step-by-step cleaning, and after which we used Eventhouse to build machine learning model. So we utilize the power of Azure AI to build a AI-driven agent, and after which we built a semantic model to showcase a Power BI report and a user interface for the agent.
I'm going to walk you through how we are using medallion architecture in Microsoft Fabric for our disease surveillance pipeline. We were able to ingest data from two sources, and one, we have an API that provides structured health reports, and a CSV file that contains mobile health reports from different counties in Kenya. We begin with the bronze layer, where we are able to use a notebook to ingest the raw data from the API, and we're also able to use a Dataflow Gen2 to ingest the data from the CSV file. From here, we were able to perform the initial transformation process, where we were able to use a notebook to clean, to perform initial cleaning for our API, and also to be able to convert it to a CSV table where we can be able to read it from our medallion architecture. From here, we move to the silver layer, where we are now able to perform data cleaning and transformation. We can see here that we were able to clean our data using several Dataflow Gen2s, where we were able to clean the data from our API now, and we can see that we're also able to clean our mobile health reports. Some of the cleaning that we're able to handle in this stage were handling inconsistencies in the data. We were able to fill missing values, and we were able to convert the timestamps to the format that was consistent with our data. And moving on, we will now move to the golden layer, and here we create aggregated business-ready tables. So these tables are optimized for machine learning predictions, AI insights, and dashboards that helps public health officials track trends and make predictive and proactive decisions. In this machine learning notebook, we first begin by loading our datasets from the Lakehouse, and then we create the year and month columns for join. So this enables us to enrich the data and be able to join the datasets on the county, year, and month columns. Next, we select the relevant features, and for this case, we are selecting the county, disease, reported cases, and reported deaths. And then we are converting these categories to numeric using a string indexer. Next up, we assemble all the features, and then we get to train the model. And here we are training using random forest regressor, and then we are able to evaluate the model, and then we save the final results in a table that we are calling it the disease surveillance predictions table, and you can see that the table is saved in our gold lakehouse. After building our machine learning model, we now want to use this notebook to create an AI model using Azure OpenAI. First, we begin by setting up our API keys and our endpoints, and then next up, we now give the roles to our model, and we are telling it what we want it to do for us. Next up, we want it to read from our predicted tables, and so we are using our disease surveillance predictions to read. And then next, we are giving a sample question, and so we are asking it which county had the highest number of predicted cases and other roles that we want it to do. and we are saving this table as a machine learning predicted insights, and you can see that we have been able to get insights from this table, and our table is saved.
Alongside, we created a Power BI report directly connected to semantic model built in Microsoft Fabric. Using the Gold Lakehouse layer, we define relationships across 4 key tables: disease surveillance, health facility reports, mobile health reports, and machine learning predictions, enabling a unified data view. The report lets users filter insights by county, as shown on the interactive map. You can instantly see total reported and predicted cases, mobile health submission, and a bar chart breakdown by county, all dynamic updating based on selected filters.
With the predicted outcomes for the disease, we were able to create AI agent that you can chat with, just like talking to a colleague. Imagine you are a health officer trying to make sense of disease pattern across the country. Instead of sifting through spreadsheet, you can simply ask, what's the forecasted malaria trend in Kisumu next month? And just like that, the agent gives you an instant, accurate response powered by machine learning prediction from Microsoft Fabric Lakehouse. But it doesn't stop there. You can also say, show me a graph of predicted cholera outbreaks in the coastal region. And in seconds, it visualizes the trends, enabling fast, informed decisions. This AI agent brings together Fabric, Azure OpenAI, our machine learning models to make disease surveillance more proactive, accessible, and intelligent. It's more than a chatbot, it's a health intelligent partner.